Hello and welcome to this review for balancing chemical equations. And what we have here, we have a chemical equation where we're taking copper and we're adding it to silver nitrate, and we're getting copper 2 nitrate out of this and silver. Now, how would I know that this is copper 2? Well, if you look on your ion chart, you'll notice that the Ag is a +1 and the NO3 is a -1. We don't have to worry about these because they are all balanced. But let's take a look at the parts of a chemical equation before we go about balancing. So when we look at this top part right here, these are called the reactants. Think of them as the ingredients. Okay? The arrow sign means this is what you're going to get. This is what you're going to result in. And then here we have copper 2 nitrate plus silver. Those are called the products, not the reactants. These are the reactants, and these are the products. So what we have here, for example, is what they call a single displacement reaction. Okay? But we're going to talk about displacement reactions and all that on another video. I want to go and focus just on how do I balance this. Well, first thing I would do is I would have to make a dividing line. I have to make a dividing line so I can separate my reactants from the products. So what are my players that I have here? Well, I have copper, I have silver, and I would have to do the same on the other side, copper and silver. Now, do I have to separate the nitrogen and the oxygen, the 3 oxygens? No, I don't. Here's why. Because I have the NO3 here, and on the product side, I also have the NO3 there. So I don't have to worry about that. I can go ahead and say, all right, the NO3s, I take that as an item. They're BFF. Think about it that way. Okay, so now we got that. Let's take a look and see how many of each do we have. Well, we have 1 copper, okay, 1 silver, and 1 NO3. Over here on this side, we have 1 copper, 1 silver, and 2 NO3s. So that's what we have. Now, the idea about balancing a chemical equation or balancing a chemical reaction is that we have the same number of coppers on both sides of the arrow, the same number of silvers on both sides of the arrow, and the same number of NO3s on both sides of the arrow. Now, do these numbers have to be the same? No, they don't. Now remember, when you're balancing, you're not worried about these numbers. Like NO3, you don't get to change the O, the number of O's. That's fixed. What you can do is put numbers in front here, and that's what we call the coefficients. So right now I'm looking at copper, I don't see any problems there. I'm looking at silver, I see no problems there, they're all balanced. Now I look at the NO3, there's 2 of them here, 1 of them here. That means I only have one choice. I have to put a 2 in front here. Okay, now that's going to change. That changes something. What is that going to change? It's going to change the number of silvers I have, because 2 times 1 gives me 2 silvers, and 2 times, there's the NO3, we've got 2 of these NO3s. And you'd say, but wait a minute, why do I don't need parentheses here, but I need it over here? Why? Well, the Ag has only got a +1 charge. The NO3 is a -1 charge. So they're together as an item. Okay, so this is what we have here. Here we need 2 of these NO3, so we have to put the parentheses there, just as a quick reminder. Now, so our coppers were good, our Ags, oh, we're not. But our NO3s, we are. We're good to go. So what do we need to do to fix the Ag? Well, we can make this a 2. We could put a 2 in front of the Ag, can't we? And that is very easy to balance out, because now we made this a 2. So now we have 1 copper on both sides, 2 silvers on both sides, because we got 2 here, and then 2 here, and then we have 2 NO3s on both sides of the equation. We're good to go. We're fantastic. Okay, so this one is balanced. I hope this will help you guys out. So we're going to do another one. Here's another one where we're going to take carbon and we're going to burn it. You could look at it as charcoal, if you will. We're manufacturing carbon dioxide. I'm not sure why, but we are. So I'm going to go ahead and I'm going to do my dividing line again. Who are my players? Well, my players are the carbon and the oxygen. And I have carbon here and the oxygen here. Okay? Now notice the O2s, they don't seem to change at all. So I mean, could you sit there and put an O2 here? You could if you wanted to, but I would not do it. And here's why. Because this is not typical. You're not going to find that. So just stick with just O. C and O, those are your main characters. So how many C's do I have here? I have 2. How many C's do I have on the product side? 1. Now I've got 2 oxygens here, and then I got 2 oxygens here. So this is what I've got. Okay, so I know my oxygens are balanced because there's 2 on both sides. We're good. And then we have 2 carbons here and 1 carbon here. So we have to change that. We cannot put a 2 down here. That is not okay because then it's C2O2. That completely changes it. It's not CO2 anymore. So we're going to put a 2 here. All right, and we're going to cross that out and we're going to make this a 2. So now we have 2 carbons, but now it's also changed this because now it's 2 times 2 oxygens gives us 4 oxygens. Oy, but you know what? It's not that bad. And here's why. Because we got O2 here, we have 4 oxygens on this side. We did not do anything on this side. We're going to make this easy, guys, because we can go ahead and put a 2 right here. We can put a 2 right there, and 2 times 2 gets us 4 oxygens. So now let's check if it's balanced. Well, our carbons seem to be balanced. Good. And then our oxygens, same number on both sides. Now notice the 2 carbons and 4 oxygens, they don't have to have the same number. What has to be is that the carbon has the same number on both sides of the arrow. The oxygen has to have the same number on both sides of the arrow. That's it. So this one, ladies and gentlemen, is in fact balanced. Okay, let's go ahead. Let's do one more here. And this one, we're going to break this up. We're going to take water. We're going to add some electricity to it. All right, and we're going to get O2 plus H2. So we're breaking the water up as our equation. So we're going to go ahead and we're going to look at this. So we got our 2 main characters. We have hydrogen and we have oxygen. Hydrogen and oxygen. So let's take a look at this. So we've got 2 hydrogens on this side, 2 hydrogens on this side. We have 2 oxygens on this side, 1 oxygen on this side. Okay? Now the question comes down to is, what do we have? How in the world do we go about solving this one? Well, I don't have to mess around with the hydrogens. I'm good to go. It is the oxygens. Again, I cannot put a 2 here because that makes it H2O2, and that's hydrogen peroxide. That's not water. That's something more dangerous than water in its pure form. Not the hydrogen peroxide you buy at the store because that's watered down, seriously. That'd be a subject for another video. So, what am I going to do? Well, I need to put a 2 here. This is the only way I can do this. Okay, and that's a very important thing. So 2 times 2 gives me 4 hydrogens. 2 times 1, remember they never show the 1 here, that gives me 2 oxygens. So now I've got 4 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. This is looking good, but now I got to figure out the last one. How do I make this a 4? Well, this is pretty easy. We can't erase the 2 and add a 4 to it. We cannot do that because we changed it and it's physically impossible. But we can do this. We can go ahead and add another coefficient in there and make it 2 times 2. That makes this 4. So, 4 hydrogens going all the way across, 2 oxygens going all the way across. And ladies and gentlemen, that is the idea about balancing a chemical reaction, or you could look at it as balancing a chemical equation. The idea is that you have the same number of the same element on both sides. Now, does this number have to match this one? No. It's that you go across and these numbers need to match out this way. That's how you would solve it. Thank you so much for watching, and I hope this helps you guys out. Take care.